All right, so before we start actually doing mathematical content per se, we're going to talk a little bit about what I consider to be some of the building blocks of mathematics. And so mathematics, I think, really has a fundamental start in what we call logic. And I want to kind of give you guys a little introduction to logic so that you have an idea. Again, if I say statements later in the course, I want you to have a pretty good idea as to how we might go about looking at those statements. So our very first chapter, we're going to do a little bit of work in logic, and the first lesson that specifically we're going to take a little bit of time today to talk about are statements. So, I mean, in its easiest sense, let's just define what a statement is. Wow, it's been like a month since I've written anything. This is weird. If there's a word that doesn't make sense, just let me know. So a statement is a meaningful sentence, so it has to carry some kind of meaning with it. And that sentence has to either be true or false. It has to be one or the other. Maybe I should have become a doctor. I don't have the best penmanship. Now, according to this definition, that means that a statement could potentially be true sometimes, false other times, but the real key to this definition is that a statement can't be true and false at the same time. So let's explore this definition with a couple examples to give you an idea of sentences that are statements. We'll talk about sentences that aren't statements. And we'll also try to figure out how we feel about the truth of some of these simple sentences as well. So the first sentence we'll take a look at is Canada has only 5 provinces. Now, it's been a hot minute since I've done any geography, but I have a pretty good feeling about this particular sentence. Do you believe it to be truthful or falseful? Totally false. How many provinces do we actually have? 10? 12? 10? Can someone fact check Alyssa? 10? Okay, we have 2 10s. 10s across the board, anyone? Okay, totally false. Now we're counting, right? I'm like, yeah, I'm pretty sure it was 10 provinces and 2 territories because the Maple Leaf had 12 points on it. I feel like I learned that in elementary school. But anyway, let's take a little peek here. So we have British Columbia, follow me along. Let's make sure we don't miss anything. I think Alberta's beside us, right, unfortunately. And then Saskatchewan is in the middle, and then we have Manitoba. And then beside Manitoba, I believe, is the gigantic Ontario, followed by the gigantic Quebec. And then we have all of those provinces over there, like Newfoundland, we got Prince Edward Island, you have New Brunswick and Nova Scotia. Is that all of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nice. And yes, 3 territories, but the territories aren't part of this discussion. Poor territories. Okay, so this is false. We definitely have 10 provinces. Since this sentence has a definitive truthfulness or falsefulness, it has to be a statement. So in other words, when it comes to statements, a statement is something that you can either argue to be true or argue to be false, essentially. So if you're thinking about it from like a debate kind of view, that's sometimes how I think about logic, is like, can I prove this thing to be truthful, or can I find evidence to show that this is false? If you can do that, then it's a statement. So the second one, let's see, there exists a red car. How do you feel about that one? Does it seem plausible that somewhere in this wide world of ours there might be a red car out there? Do any of you have a red car, by the way? Excellent. So Laura is our example. Laura has a red car. Done. We found one. There exists a red car. Laura has it. The only one. The only one in existence is at Laura's house and or apartment. So this is a sentence. This sentence is a statement because we know that it's always true. Now, sentences can get a little strange. So here's one that's a little bit weird. So the sentence is, Terry Fox met exactly 1,000 people from Ontario. How do you feel about this one? Yeah, this is one of those like weird cases where I'm gonna argue that this is a statement, but I totally understand why you might think it's not, because it could be true or it could be false. We don't know which one it is, but what I want you to know is that it's got to be one or the other, right? So either he met exactly 1,000 people from Ontario, or he didn't meet exactly 1,000 people from Ontario. It's either true or false, but it's not both at the same time. Does that make sense? I don't know what it is. I don't know if this is true or false. I'd have to actually do some research and, maybe go back in time and talk to Terry Fox, which I probably can't do at the moment. But I know that this is either true or false. It's got to be one or the other. So because of that little discussion, I'm going to say that this is a statement. It's just a statement that we don't know the truth value of without knowing a little bit more information. Okay, let's look at a mathematical sentence. Okay, so here's a mathematical sentence. X plus 5 is equal to 8. I know, day one and we're already doing algebra. Hot damn. Tell me what you know about this sentence. Can you tell me anything about this sentence? For example, what might X be? Yeah, so I think some of you have kind of the moving forward idea here. We don't need to find X. It's just a sentence. I haven't told you to do anything with it, but knowing what X could be is important here. It's true when X is equal to 3, right? Okay, so being able to solve for X is an important idea. It tells us when this sentence is true. It also tells us when this sentence is false. So for example, what if X was equal to 5? If X was equal to 5, well, that's not right. 10 isn't equal to 8, right? Do you see that? So if X is not 3, you run into this problem where you have an equal sign and you get numbers that don't match on either side of the equal sign. So it's not a truthful statement anymore. So it's true when X is equal to 3, but this sentence is false when x is not equal to 3. So this is kind of like a conditional kind of thing. It's kind of like this Terry Fox example, right? With a little bit more information, we don't really know when this is true and false. But notice that if we pick a value for x, this sentence is either going to be true or it's going to be false. It's never going to be both at the same time. The sentence is dependent on our choice for x. Does that make sense? So like I said, it's one of these kind of weird examples, kind of like the Terry Fox example, where it's sometimes it's true, sometimes it's false, but it's never both at the same time. So this is another example of a statement. It's just a kind of conditional statement. It's kind of dependent on some more information. Oh, hello. I have puppy visitors this morning, so you can't not give your dog some pats, right? You can't not give your dog some love when she comes to visit you in your office. Okay, last one. This one is a little bit silly. Well, actually, we'll do two more. We'll do two more. So let's do this one. So I figured I would try to give an example of a non-meaningful sentence, I guess. So inside the definition, it says it should be a meaningful sentence that's either true or false. So every once in a while, we run into these sentences that are a little bit more subjective. So I don't know. It looks kind of crappy outside. It looks kind of windy, and I know it's winter. So maybe we could argue that it's not hot outside. But maybe there's somebody that like lives near the North Pole and they come and visit and they're like, it's really hot outside right now. So I want you to notice here that this sentence that we have is, the word hot is kind of subjective, right? Like how hot, like if there was like degrees associated with this, or if there was like some kind of component where we could actually measure, that would be easier. But we run into this issue here with the word hot, essentially, right? I don't know how to measure that. I don't know how to figure out if that's true or figure out if that's false. So we kind of describe this as a like non-meaningful sentence or like a subjective sentence. So we can't really talk about this as a statement, if that's helpful. Is that enough explanation? If you need to add anything there, it basically comes down to, you know, different people will view the word hot differently. And this is also dependent on like the season too, right? Like it's winter now, but if I said this in the summer, maybe it's going to be true. I don't know. I feel like the subjectivity here makes this not a statement. It makes it hard to argue one way or another, right? It's hard to place a truth value, I think, onto this one. And the last one, which we will end class with today, is fun. Okay, this one is always like the funnest example to do on day one because it literally is going to start melting your brain a little bit. So the sentence is this. This sentence is false. That's what the sentence is. Okay, so if this sentence is false, if we think that it's true, but it's saying that it's false, so we run into a problem. So if we think that this sentence is true, but it says this sentence is false, then it's both true and false at the same time. If we think this sentence is false, the sentence is false, but that means it's true. So this is an example of a sentence where it's both true and false at the same time. And that's why it's a little bit of a kind of a mind bender. So I'll try to write this down. This one's hard to write in words, but let's pretend. So assume true. Okay, so we assume that the sentence is true, but the sentence says it's false. Okay, and then we run into this situation where it's true and false at the same time. If we assume false, then the sentence says that it is false, so in which case the sentence is truthful. And you run into that case again where it's both true and false at the same time. So yeah, like Taryn, hopefully I'm saying your name correctly, is Taryn had said, yeah, the liar paradox. Yeah, it's a fun paradox. So as Taryn said, this is not going to be a statement because a statement cannot be true and false at the same time. So this is not a statement. So basically, and as just a little tiny summary, sentences like number 5 and number 6 are things that we really don't want to study in mathematics. Mathematics is more about sentences that we can deem to be true or false, or true in some instances and false in some instances, but we never want overlap. So mostly for the purpose of our course, we're going to be trying to ignore sentences like 5 and 6, and focus our attention more on these sentences that are very obviously true, sentences that are very obviously false, or maybe sentences that are sometimes true and sometimes false, and we need a little bit more information to figure out the truth value of that particular sentence. So hopefully that gives you a little bit of introduction to some of the building blocks we're going to be working with here over the next week or so. Yeah, it was a pleasure to say hello to all of you and actually see some faces this morning. So you can stick around for a few minutes if you need to ask any questions, but otherwise we'll finish off class today. If you think of anything over the next couple of days, just shoot me an email. Otherwise, I will see you Wednesday morning at 9:30.